Hello pre-calculus students, and welcome to the first video example applying the sum and difference formula for sine and cosine and tangent. So we're going to see one sine and one tangent today. So in this first example, we're looking for the exact value of the sine of 105. And the first thing to do is just kind of look at the unit circle here and notice that 105 is not on the unit circle. 105 would be a little bit more than 90. It would be right around there somewhere, right? It's 15 degrees more than 90. In fact, it would be exactly between the 90 and the 120 right here. So it'd really be kind of nice to fill in those gaps. And that's why the theme of this, and this is the first application of using the sum and difference formulas, is to fill those gaps and really finish up the unit circle, make it more symmetrical, more complete, not feel like it's got these gaps in it. All right, so the way we're going to do the sine of 105 and anything to fill these gaps is we're going to be using one of the four sum and difference formulas. And so in this particular case, so these are the four, and the two, actually there's six because there's two for tangent. In this particular case, we're going to be using the sine of alpha plus beta because we have those, we have an alpha and beta that add up to 105 that's all on the unit circle. So I'm just going to write down this formula on our page. So we're going to use the fact that we know that the sine of alpha plus beta is equal to the sine of alpha cosine of beta, and you got to be careful with the pluses and minuses here, but this is plus the sine of beta cosine of alpha. Just look to make sure we copied it right, and we did. Okay, so the reason we're using this is because the sine of 105 is the same thing as the sine of two things on the unit circle, and you should pause it if you haven't already thought about this, but what on the unit circle adds up to 105? And the answer is 45 plus 60 adds up to 105. And I didn't choose 100 plus 5 because obviously 100 and 5 are not on the unit circle, but very importantly, I chose two numbers that are both on the unit circle that I know. Okay, that's really the that's the first requirement for all these problems. So this is really going to be the sine of 45 plus 60, is equal to the sine of 45, the cosine of 60, plus the sine of 60 cosine of 45. Four things of which we know all of. Okay, so that's basically what I did here is I just, alpha is 45, beta is 60. All right, so now we just start looking at the unit circle. The sine of 45 is rad 2 over 2. Actually, I'll let you fill these in, so I'll pause it for a minute. We're going to find them and simplify them. That's pretty much all we need to do once we have this, we get to this point. Okay, so hopefully you got this far. Now we're going to simplify this. We already are fortunate in this problem to have a common denominator in both of our terms. So all we have to do is multiply 1/2 times 1, rad 2 times 1, which is rad 2, and rad 3 times rad 2, which is rad 6. And that's as simplified as we can get it. So now if we were to be putting the point in here, it's going to be an ordered pair, we now know the y-coordinate. It's rad 2 plus rad 6 over 4. Okay, let's look at a tangent. Okay, so let's find the exact value of pi over 12. Now for this one, again, we look at the trig identities, and we're going to look at the tangent, and we need either a sum or a difference that gives us pi over 12. Now, being a small number, pi over 12 is a smaller number than most of our numbers on the unit, all of our numbers on the unit circle except 0. We're going to use a difference here. So we're going to use the fact that the tangent of alpha minus beta equals the tangent of alpha. Let me look one more time. Tangent of tangent of alpha plus the tangent of beta over 1 minus their product. So it's going to equal the tangent of alpha minus tangent of beta over 1 plus their product. Okay, so just like we needed with the sine and cosine, we need some alpha and beta that either, in this case, subtracts to give us pi over 12, but we need values that are on the unit circle. Now, if you don't like to think in radians, you can always convert this to degrees. This is 15 degrees, and you'll be able to figure it out that way. I'm going to just think in radians a little bit here. This is in 12ths. I know that this is going to be, well, you have a couple choices here. This is 4 pi over 12 minus 3 pi over 12. That's 1 pi over 12. You could also do 3 pi over 12 minus 2 pi over 12. That's also 1 pi over 12. And they're both going to work, and they're both on the unit circle. Because this is just pi over 3, this is pi over 4, this is pi over 3, and this is pi over 2. So take your choice. I'm just going to choose this one. And so what I end up here is I want to say that this is the same thing as the tangent of pi over 4, because that's 3 pi over 12, minus pi over 6, because that's 2 pi over 12. And that's going to equal the tangent of alpha, which is pi over 4, minus the tangent of beta, which is pi over 6, all over 1 minus their product, the tangent of alpha, which is pi over 4, times the tangent of pi over 6. Okay, now we're going to convert all these into numbers and then simplify. So I'm going to pause it, let you convert it into numbers and simplify, and then we'll compare answers. So go all the way to simplifying on this time. Okay, so how do they look? So first of all, I had to change this to a plus, so hopefully you guys noticed that I had a plus here and I made that a minus, but I changed that. Okay, so check your final answer. The final answer of the tangent of the tangent of pi over 12 is 2 minus rad 3. That would go right here. This is 2 minus rad 3. And that's pi over 12, or 15 degrees, since this is in degrees. Okay, and let's see. Notice that I had to first, just in case you had any trouble here, first just plug in the numbers, and then once we have the numbers, I got a common denominator here. So that's why I multiply these ones by 3 over 3, so I get a common denominator of 3. I then canceled out the 3's here and here. And then I went ahead, and what you did in one of your mastery quizzes is simplify this radical by multiplying by the conjugate of the denominator, which is 3 minus rad 3. Once you do that, then you have a rational denominator once everything is simplified, because these two cancel out, and that just gives you the 6 in the denominator. And then we just divide, reduce both parts of the fraction, and we'll get 2 minus rad 3. Okay, I hope you found this video helpful.